Good morning, y'all. I want to open this video with something that I almost never say on this channel because I believe in precision and I believe in being careful about language that could either alarm people unnecessarily or cause them to discount a real threat. But this morning, I am going to say it and I am going to say it clearly, and I am going to spend the rest of this video explaining exactly why it is true. The storm that is developing for the middle of this week is going to hit differently than the severe weather you have experienced in recent memory. Not differently as in more storms or louder thunder or a wider area on the radar. Differently in three specific, fundamental, structural ways that change how this event behaves, where it goes, how fast it moves, and who it threatens. And because those three differences are not obvious from looking at a surface map or a basic radar loop, I am going to walk you through every single one of them in detail this morning, because the people in the path of this storm deserve to understand not just what is coming, but why it is different and what that difference means for how they need to prepare. Let me start with the first way this storm is going to hit differently, because it is the one that has dominated my thinking since I first started watching this setup develop in the extended range model data 3 days ago. Most of the severe weather events that people in the Southern Plains experience, the ones that have been rolling through this spring, the rounds of storms that have been part of the active pattern we have been tracking, share a common structural characteristic. They develop along a boundary, they move rapidly northeastward, they produce their worst impacts in a concentrated corridor over a few hours, and then they exit. That is normal spring severe weather behavior. The system develops, it fires, it moves, it exits. The affected corridor is relatively narrow because the storm is moving fast, and communities on the northeast side of the track get warning time from what happened to communities on the southwest side. That is the kind of severe weather that the south central United States has a lot of experience with and a lot of built-in instinct for managing. This storm is not that kind of storm. What is setting up for Tuesday is built around a mid-level jet streak that is going to eject northeastward out of the southern Rockies and into the southern high plains at 60 to 70 knots. That jet streak, that river of extraordinarily fast-moving air at around 18,000 feet, is going to interact with the surface low in a way that creates explosive, rapid storm intensification over an enormous geographic area simultaneously, not sequentially from southwest to northeast, the way communities are used to tracking and responding to severe weather simultaneously. Storms are going to initiate from the Texas Panhandle all the way through central Oklahoma and into southern Kansas within a relatively short time window, all of them feeding off the same jet streak, all of them organizing rapidly into supercell structure, all of them producing tornado and hail threats at essentially the same moment across a corridor that is hundreds of miles wide and several states long. That is what makes this one hit differently. Not that the storms are stronger in any one location, though some of them may be, but that the geographic synchrony of dangerous storm development is unlike what most communities in this corridor have experienced this season. When your community's warning system is built around the assumption that you will see what happened to the town west of you and have time to prepare, a storm that bypasses that linear progression and arrives from every direction at once is a storm that hits differently. The second way this storm is going to hit differently has to do with something that most people in the path of this event would not immediately think to check, but that every experienced severe weather forecaster in Norman, Oklahoma is watching very closely right now. And the pressure gradient between that developing surface low and the high pressure system sitting over the Gulf Coast states is going to drive a powerful southerly low-level jet. Forecasts are showing this low-level jet reaching 45 to 60 knots at roughly 3,000 feet. That is going to transport exceptionally moist air from the Gulf of Mexico deep into the warm sector ahead of the approaching cold front. Surface dew points across the warm sector corridor from North Texas through eastern Oklahoma and into southeastern Kansas are forecast to reach the mid to upper 60s degrees Fahrenheit by Tuesday afternoon. mid to upper 60s in mid-April across this corridor. That moisture sitting underneath the steep mid-level lapse rates generated by the cold upper-level trough and energized by the rapid large-scale lifting from the ejecting jet streak is going to produce CAPE values in the 2,000 to 3,000 joule per kilogram range across the primary severe weather corridor. The storm relative helicity values, measuring the atmosphere's rotational capacity for tornadic storms, are forecast at 300 to 450 meters squared per second squared in the highest overlap zone, and the deep layer shear, that 0 to 6 kilometer measure of wind speed and directional change that determines whether storms organize into discrete supercells or scattered multicells, is forecast at 50 to 65 knots across the southern and central plains. Strong, deep layer shear, 50 to 65 knots, on top of CAPE in the 2 to 3,000 range, on top of helicity of 300 to 450. The SPC is already saying Tuesday afternoon and evening we'll see supercells with large hail, wind damage, and tornadoes, and that an upgrade from the current risk level will be possible once confidence increases on the timing of the ejecting trough. An upgrade means they are already considering whether this day warrants a higher risk category than what they can currently commit to days in advance. That is the language you hear before enhanced risk days, sometimes before moderate risk days. When forecasters are already talking about upgrades before the short-range models have even captured the full event, that is the atmosphere telling you to pay full attention. Let me get specific about the geographic corridor I am most focused on, because specific information is what saves lives and vague regional awareness does not. For Tuesday's primary convective initiation and the period of maximum supercell tornado and hail threat, the corridor I am watching most closely runs from the southern Texas Panhandle, Amarillo, Pampa, Borger, southeastward through the Wichita Falls area into the southern Oklahoma City metro and communities south and east of it like Chickasha, Shawnee, Ada, and McAllister, and then northeastward through the Tulsa metro into the Miami and Joplin corridor across the state line into southwestern Missouri. That is the area where Tuesday afternoon's supercell initiation corridor and the highest CIG level severe weather potential overlap most directly. Now, I want to be honest about the uncertainty that still exists at this range, because I think honesty about uncertainty is as important as honesty about the threat itself. The exact placement of the ejecting jet streak, see where it positions itself relative to the moisture axis and the surface low track, will determine whether the highest intensity corridor is displaced slightly east or west of what I just described. Models are still resolving that detail, and it is going to come into focus over the next 24 to 48 hours. What I am confident about, and what you should plan around regardless of where exactly the highest intensity corridor lands, is that Tuesday is a day when all of North Texas, all of Oklahoma, most of Kansas, and portions of Missouri and Arkansas need to be fully prepared for severe weather. The exact bullseye shifts slightly from run to run. The fact that this region is in a dangerous setup on Tuesday does not shift at all. Plan accordingly. Now, I want to talk about the timing of this event, because timing is often the most critical factor in whether communities can respond effectively to severe weather threats. And the timing of Tuesday's setup has a characteristic that I want to make sure everyone understands going into this week. The convective initiation